Hopefully you know where everything's located. Same idea, situation of the problem. This week, I wanted you to roleplay as an analyst, labor analyst working for Deloitte. You've been tasked with analyzing wage data to make recommendations on policy with respect to unemployment. So keyword there, unemployment. You could have used any of the wage data from that chapter. I chose wage 2 because I thought it made the most sense with how I could create the dummy variable we needed for unemployment, because unemployment was not in the data set. Hence why I talked about proxy variables and dummy variables in that lecture. So if you didn't watch the recording from that week, you may want to go back and watch the recording for that week before you watch this week. Wait, same idea as assignment 1, write 1 to 2 sentences incorporating what you have here into a situation of the problem. So, problem statement, it needs to be actionable statement based on what you're doing for the company. I gave you an example in assignment 1, so same idea based on assignment 2, draw it to what it is Deloitte is asking you to do. Analysis. Okay, same idea. You have your variables. You realize you don't have unemployment. You need to create that dummy variable. You can run some descriptive statistics and talk about that, exploratory data analysis, etc. Basically, what do you have to work with? So that's what we'll get to here. So once again, I'll go over. You have to install the Wooldridge package to get the library that we need. This week, you will need NumPy probably, because that's how we will create a dummy variable. This is where the data is located, so make sure you have that library imported. This is how we're going to run multiple regression. And here is how to pull the data in. So like I said, I chose wage 2. You'll see why in a minute. So I pull it in. Then I look at the wage 2 info. I look at all the variables, wage, hours, IQ, KWW, education, etc., etc., etc. And basically what I realize is there's nothing dealing with unemployment, right? So that's why I talked about creating a proxy variable. So we have to figure out how to do that, but we'll get to that in a second. Okay, so let's look at descriptive statistics. We can kind of see the ranges of the data we're working with, what it looks like, etc. Like I said, for assignment 1, we can pull the descriptions in here. So I say, oh, okay, so I'm working with wage data, monthly earnings, so that's going to be key. I have how many hours they're working, what's their IQ score, knowledge of world work score, years of education, experience, tenure, how long they've worked with a current employer, which may be tough with if they're unemployed currently. Their age, whether or not they're married, whether or not they're white or black, or I mean, I really wish this data had more ethnicities to pull in, but if they live in the South, so maybe unemployment's higher in the South, I don't know, we'll find out with the analysis. If they live in an urban area, number of siblings, birth order, mother's education, father's education. So natural log of wage, well, we'll only want to use one or the other, right? So it just depends on how you take it. Now, the important part for creating the dummy variable comes from this part in the bottom. So it was published in this journal, and the data that this person is using came from 1980. So I looked up what was the minimum wage in 1980, and it was $3.10. So assuming they work 40 hours a week, there's 4 weeks in a month. I multiplied 3.10, the minimum wage, times 40, get 496. And based on the wages, monthly earnings, I decided that they were probably unemployed, maybe on unemployment benefits. I don't know. This is just kind of my logic and thought process. I created this dummy variable unemployed and using NumPy and the where function. I said in that data set, if the wage is less than what we just calculated out was the minimum wage at the time, it's 1. So I'm basically creating a binary saying you're likely unemployed if you make less than this amount. Otherwise, you're not. All right, so I created that. When you run that code, now we can go back and check that it's in there. So if I run info, you can see now I have unemployed. If I run descriptive statistics, I can see that based in our data set, 28% of the people, let's see, that's standard deviation, 8% of the people, because that's the mean, are probably unemployed. And then we're expecting a min-max value of 0 and 1 because it's binary. So we know that less than 10% of our sample is going to be considered unemployed. So let's look at what factors may be causing people to be unemployed or considered unemployed on unemployed benefits, etc. at this time. So basically, I just took my dummy variable and I took all of the variables that are in the data set except log wage, because it would be a duplicate and then we'd have multi-collinearity issues. And then I ran that and I get this multiple regression. And so we have to use adjusted R-squared because it's multiple regression. My model explains 21% of the variance. The model's worth looking at because the F statistic was significant. Then I need to go through and analyze all of these p-values and the magnitudes of the coefficients. So I put that into Word so I could highlight. So here are the variables that were significant: wage, hours, IQ, tenure, married, South. So those are the variables worth continuing our analysis on. So identification of possible solutions would be anything based on the variables that we had to work with, right? So like I said, this step would have been written prior to actually running the analysis because you need to think, well, what variables may have an impact? Then evaluation of possible solutions. This is where you actually run the multiple regression and interpret the coefficients to help you determine which solutions are feasible. So based on that, I would draw that the highest magnitude coefficients are tenure, married, and South. So those would be the variables of interest. So then I would analyze those. We can say that married is the highest magnitude coefficient. Actually, it's negative, so that's good, right? So if you're married, then it will bring your coefficient down, and 1 we said was unemployed and 0 is employed. So going something along the lines of marriage may be a direction to go, which makes sense if you think about income tax, right? You file income tax if you file single, you don't get as much money as if you file married, right? So there's already kind of something in our legislation for that. Second highest one is if they're in the South. So maybe talking about policy specific that would help the South. That's kind of the recommendations and direction I would want you to go, and then decide, what's the best one? Recommended course of action. Pick the one best solution of the 3 and why? Probably going to have to deal with the highest magnitude one, unless you can say, let's say if you're trying to say South was more important, you'd have to come up with some logic to why you would pick South over married, even though married's coefficient is higher. But being in the South, it has a positive coefficient, right? So it's causing that to go up. So being in the South, you're more likely to be unemployed. Okay, and then implementation plan. Once again, you just need to tell who needs to do what. You're presenting this to, go back to the top, presenting this for policy recommendations, right? So I assume this is going to be a government-based setup, presenting to House of Congress and saying, look, we need to make changes based on my analysis, and who needs to do what? What do we need to do with the legislature to make this change. And that's kind of the direction I would have gone with this one.